Hello and welcome to our channel. In the endless darkness of the sky, where nothing but silence and emptiness exist, an incredible process begins. Stars, the hearts of galaxies and giant creations that shine as sources of light and energy in the cosmos, are born in this darkness. Today, we embark on a journey into the gas and dust clouds that hide the secrets of the universe. Get ready to see how these fiery spheres are formed and light up our world. What is a star and how does it form? Stars are plasma bodies that derive their energy and light from nuclear fusion in their cores. This energy is produced by burning hydrogen and converting it into helium. Stars remain stable due to the balance between the inward gravitational pressure and the outward energy pressure, preventing them from collapsing. Stars are the primary components of galaxies and are among the first objects of the early universe. The Sun is the closest star to Earth, followed by Alpha Centauri, which is 4.3 light-years away. How do stars form? Stars are born in nebulae or molecular clouds, which consist of dust and gases like hydrogen and helium. These clouds, under the influence of gravitational forces or shockwaves from supernova explosions, begin to spin and form clumps. As mass and temperature increase, a protostar forms, and once the temperature reaches 10 million degrees Celsius, nuclear fusion begins, turning the protostar into a star. Star nurseries like the Orion Nebula are places where new stars are born. How do stars die? Stars die when they run out of fuel and the process of nuclear fusion comes to an end. First, hydrogen turns into helium, then helium into heavier elements like beryllium, and finally iron. With the completion of these processes, stars undergo significant changes, and their fate depends on their initial mass. The fate of smaller stars, less than 8 times the mass of the Sun, after burning out and dispersing material into the surrounding space, they turn into white dwarfs. This process involves the formation of a planetary nebula from the star's dispersed atmosphere. Larger stars, more than 8 times the mass of the Sun, after fusion stops, the core becomes compressed, and collapse occurs, resulting in a supernova explosion. The result of this process is a neutron star or a black hole. How do stars die? Stars die when they run out of fuel and the process of nuclear fusion comes to an end. First, hydrogen turns into helium, then helium into heavier elements like beryllium, and finally iron. With the completion of these processes, stars undergo significant changes, and their fate depends on their initial mass. The fate of stars, the fate of the Sun and similar stars, the Sun and stars of similar mass will grow larger over billions of years, and eventually, once fusion stops, their atmosphere will spread into space, and they will become white dwarfs. The role of star deaths in the universe. The death of stars results in the distribution of chemical elements produced in their cores into space, forming gas and dust clouds. These clouds create the seeds for the next generations of stars and planets. Types of stars and their colors. What is a star and how does it form? Astronomers classify stars based on various characteristics. Stars come in different sizes and colors, and studying these characteristics helps identify the type of star. One of the most important criteria for classifying stars is their spectrum. To determine the spectrum of a star, its light must be analyzed. Based on this, stars are generally divided into 11 categories, identified by the letters O, B, A, F, G, K, M, R, N, T, and Y. This classification indicates the temperature, luminosity, and color of each star. For example, type O and B stars are the hottest, with temperatures between 30,000 and 40,000 Kelvin and a bluish color. Type A stars are blue-white, with a temperature of about 9,500 Kelvin. Type F stars are white, with a temperature of 7,500 Kelvin. Type G stars are yellow-white, with temperatures between 5,900 and 6,000 Kelvin. Type K stars are orange, and Type M stars are red, with temperatures ranging from 5,300 to 3,800 Kelvin. The coolest stars are called brown dwarfs, and they are classified by the letters R, N, T, or Y, depending on their temperature. Brown dwarfs have a temperature of 1,000 Kelvin or lower. A brown dwarf is not hot enough to be considered a star, nor cool enough to be a planet. Brown dwarfs emit some light but do not have enough heat to initiate nuclear fusion, so they eventually cool down and extinguish. Chinese astronomers were the first to observe and record a supernova in 185 AD. The supernova is now known as SN 185. Hertzsprung-Russell diagram. The color and luminosity of stars can be organized into a diagram called the Hertzsprung-Russell diagram. Stars that are in the hydrogen burning phase are called main sequence stars, and this sequence is represented by a curve in the diagram. Most stars in the universe are main sequence stars, but white dwarfs, red and blue giants, supergiants, and hypergiants lie outside this curve, meaning they have already burned their hydrogen and are now burning other elements, passing through later stages of evolution. According to astronomers' estimates, the Milky Way galaxy contains about 1 trillion stars. Molecular cloud collapse. The collapse of a molecular cloud, driven by gravitational forces, heats up the cloud, transforming it into a protostar. Although the cloud remains cool, it is extremely large, with a diameter sometimes 20 times that of the Sun. As a result, its surface area is vast and, consequently, very luminous. As energy is released, gravitational pressure compresses the protostar, causing it to shrink, which increases its temperature and reduces its overall luminosity. When the temperature of the core of the protostar rises to 10 million Kelvin, equivalent to 10 million degrees Celsius, the nuclear fusion barrier between ionized hydrogen atoms, protons, is broken, and nuclear fusion begins. Hydrogen burns and is converted into helium nuclei, releasing energy. Initially, the radiation pressure directed outward cannot overcome the gravitational pressure of the star's core, but it weakens the effect. The star's surface temperature increases significantly, compensating for its shrinking size, and the star's luminosity gradually increases. At this stage, the star moves slightly upwards and to the left on the Hertzsprung-Russell diagram over the course of about 10 million years. As the fusion rate increases due to the rising core temperature, the outer gases and radiation pressure eventually balance the inward gravitational pressure. The star reaches hydrostatic equilibrium, which may last for several tens of millions of years. Stars visible to the naked eye. The human eye can see 9,096 stars in the sky. The best time to observe the most stars is on nights with a very thin crescent moon and little artificial light. On dark nights, from any point on Earth, a person can only see about 2,000 stars with the naked eye. Stars are born in groups and in regions known as stellar nurseries. Over time, they move across the galaxy, distancing themselves from their birthplaces. Most stars travel through the galaxy in clusters, but not all stars do so. For instance, the Sun moves through the Milky Way without accompanying stars. Past of stars. When you look at a star, you are actually seeing its past, not its present. Since stars are so far from Earth, it takes a long time for their light to reach us. For example, although the Sun is the closest star to Earth, its light takes 8.5 minutes to reach Earth. So when you look at the Sun, you are seeing it as it was 8.5 minutes ago. The further a star is from Earth, the more pronounced this effect becomes. For example, the Alpha Centauri star system is so far away that its light takes 4.3 years to reach Earth. When you look at the stars in Alpha Centauri, you are actually seeing them as they were 4.3 years ago. Some stars are so distant that their light takes millions of light years to reach Earth. The lifespan of stars. The greater the mass of a star, the shorter its lifespan. Very massive stars may live for only tens of millions of years, while a cool dwarf star can shine for billions of years. The current age of the Sun is estimated to be 4.5 billion years, and it is currently in its middle age. The Sun is a G-type star and a yellow-white dwarf that formed about 4.6 billion years ago and is still burning hydrogen into helium. This nuclear fusion process produces energy and causes the Sun's luminosity. It is expected to continue in this state for over 5 billion more years. After the hydrogen runs out, the Sun will begin burning helium and other heavier elements and eventually become a white dwarf. During this process, the Sun's volume will increase drastically, and its outer layers will turn into gas, forming a planetary nebula around the Sun. After this phase, the Sun will gradually cool and shrink, a process that will take between 10 and 15 billion years. Alpha Centauri is the closest star system to the Sun, consisting of 3 stars, Alpha Centauri A. This star is a G-type star, similar to the Sun, and is about 4.3 light-years away. Alpha Centauri B. This star is a K-type star, relatively dimmer and has less mass than the Sun. Proxima Centauri. This star is the closest to Earth in the system and is an M-type star. It is the dimmest member of the Alpha Centauri system. Sirius, also known as Dog Star, is the brightest star in the night sky and is located in the constellation Canis Major. Its distance from Earth is 8.3 light-years. Sirius is actually a binary star system, consisting of 2 stars. Sirius A. This is an A-type star, twice the mass of the Sun and 25 times more luminous. Sirius B. This is a white dwarf star, slightly less massive than the Sun, with much less luminosity. Sirius has been significant throughout history, used for timekeeping and navigation in ancient civilizations. Scuti is a red supergiant star, with a radius 1,708 times that of the Sun. This star is one of the largest stars in the sky, with a diameter of around 2.4 billion kilometers. Its luminosity is variable, changing periodically. Astronomers believe no star can have a radius larger than 2,000 times the Sun, making Scuti one of the few stars close to this limit. R136A1, located in the Tarantula Nebula in the Large Magellanic Cloud Galaxy, R136A1 is one of the most massive stars known, with a mass 256 times that of the Sun. This star is visible from the southern hemisphere, and astronomers are uncertain how much longer it will survive. Upon the end of its life, R136A1 could transform into a neutron star or black hole after a supernova explosion. Vega, also known as Alpha Lyrae, is the brightest star in the Lyra constellation. It rotates rapidly, causing it to have an oblate shape. Vega has twice the mass of the Sun and is about 400 million years old, relatively young. It is consuming its nuclear fuel at a fast rate, meaning its lifespan will be shorter than that of the Sun. In the future, Vega may evolve into a supernova. Betelgeuse, also known as the Shoulder of the Hunter, is a red supergiant star located 650 light-years away from Earth. It is one of the stars that might eventually explode as a supernova. Astronomers predict this explosion could happen in a few million years, which is short in astronomical terms. Antares is a red supergiant star located in the Scorpius constellation. It has 10,000 times the luminosity of the Sun and is 18 times more massive. Antares, as one of the more massive stars, could explode into a supernova within the next 100,000 years. It has a companion star, Antares B, which is smaller and less massive than the primary Antares star. Rigel is one of the brightest stars in the Orion constellation, with 120,000 times the luminosity of the Sun. It is a B-type star and has a binary companion of similar stars. Rigel's luminosity varies, and it is one of the most studied stars in the sky. It is often observed as the brightest star in the Orion constellation at different times. And that's a wrap on today's journey into the formation of stars. We've seen how these majestic giants are born, live, and eventually meet their fate in the vast cosmos. If you enjoyed the video, don't forget to like, comment, and subscribe for more cosmic adventures. Until next time, keep looking up. Who knows what you'll discover in the stars?